so we're going to add to inverse trig functions. So get your journals out, and we will add to them. You studied already that we have cosine and sine, what quadrants they fall in. So to begin, remember that when you set this up, cosine was allowed in these quadrants, quadrant 1 and 2. Sine was allowed in quadrants 1 and 4. And what I mean by allowed, remember it's the inverse of them, right? And when we drew a picture of sine and cosine, this picture does not pass a horizontal line test, which means sine's inverse and cosine's inverse are not, they're not actually a function. So what we did is we took just a piece of it so that we can still use it as a function. And when you take a piece of it, the part that we're allowed in cosine is quadrants 1 and 2 from 0 to pi. Okay? In sine, you're allowed from pi over 2 to negative pi over 2. Right? And tangent is the same place as the sine, and that's the part that we're adding today. The other thing I want to be sure you remember is the reciprocal of sine. What is it? Don't remember? Cosecant. Excellent. And the reciprocal of cosine is secant. Remember that you know because of the letters S and C, and then the reciprocal of C starts with an S. That kind of helps. And then we have tangent, and the reciprocal of tangent is cotangent. The other thing that, in case you've forgotten, but that's really important, is that sine represents y and cosine is x, right? Because cosine is the adjacent, the x-axis. Right, so those are the little things to remember. What we're going to do is try some problems that are harder than yesterday. All right, so we're going to start easy and get harder. Start with number 1. Okay, the inverse of sine, notice it starts with a capital S. We know it has restrictions, okay, of 1. We start easy. That's what we did yesterday. Find me, use your purple unit circle, okay, and the inverse of sine. Sine is y. Where is y? 1 at. Okay, good. Way up here at the top. So you're in this spot. And I want to know, I gave you an outside value, right? So you're going to give me the radian. Good. What's the radian there? Pi over 2. Okay? Good. Okay. So now let's move to the next one. The answer was pi over 2. Right here. Number 2. If I asked you for the inverse cosine of 0, the inverse cosine of 0. Remember, cosine is allowed here. Here's where you're allowed. It's important, the inverse. When is cosine means x? It's the first thing you should say to yourself. Okay, I'm thinking about x. When is x 0? When is x 0? X is 0 here and here. But you're not allowed down in the bottom, so that doesn't matter. So this is the answer. So what radian is it? Good, pi over 2. Feeling okay about it? That's yesterday's. Let's do another one. Number 3. The inverse tangent of a negative root 3. The inverse tangent of a negative root 3. Look at your tangent values. Tangent is allowed here and here. Tangent's only negative, right? We only have a negative tangent. 2 and 4. They're only allowed in 4. So I'm this spot. But is my answer 5 pi over 3? No. What are we going to call it? Right. Yeah, look at negative pi over 3. It's the same spot as this. I counted down 3. So the answer is negative pi over 3. Okay? Let's try it. Number 4. Cosine of the inverse tangent of 1.
Oh.
Cosine of the inverse tangent of 1. I know, I'm sorry about the glare. I can't get this right since it doesn't. Start in the middle. Start right here. What is tangent, inverse tangent of 1? Tangent is only allowed in these two spots. So look at your tangents. Where is it 1? It's 1 and negative 1. So we're here. So it's pi over 4. So this value is pi over 4. So I now have a new problem. I want cosine at pi over 4. Okay, this is a little different because it says I want cosine at pi over 4, but it's not an inverse. It's not capitalized and it doesn't have a negative 1. Okay, this next sentence is important. Listen to me. When you don't have a negative 1, it means you're not an inverse. You're just a plain old cosine. Guys, this will confuse you. It means you're allowed to go anywhere you want to go on the unit circle. There's no restrictions, right? There's only restrictions if there's an inverse. So that will confuse you later. So do me a favor, find, it just so happens, I'm going to erase what I had, and I want cosine of pi over 4. I'm giving you a radian. It's because I'm not asking for an inverse. I didn't flip x and y. So I'm giving you an inside value, a radian value, and I want you to find it. So here's pi over 4. What's cosine? Root 2 over 2. This is the cosine. Here's pi over 4. This is the x value, the cosine value. So the answer is root 2 over 2. Root 2 over 2. Okay, let's try another one. We aren't going to do too many. These really are just kind of problems where you just practice on your own. Number 5, right? Yep. Okay, let's try the inverse cosine of the cosine of 4 pi over 3. It's hard to read. I'll write it on the board. This is what it says. You start in the middle. You're going to start here. Find 4 pi over 3, but at first you're going to worry because 4 pi over 3 is way down here. Here's 4 pi over 3, and you're like, wait a minute, I'm not allowed in quadrant 3. Why? Why am I allowed there? Good. It's not an inverse. Excellent. You can go wherever you want. Okay? Right? Cosine is a function. Its inverse is what's not a function. Do you see what I'm saying? If you drew a picture of cosine, yeah, it passed a horizontal line test all day long. You're fine. It's its inverse that isn't a function. Yes? I want cosine. So cosine is negative 1/2.
No, I'm talking about for the inverse.
I'm not there yet. Hang on. Let me finish. So I'm at the inverse of this value here is negative 1/2. Negative 1/2. Okay. So then the next step would be to find this. So when is x negative? Here's my x-axis. It's negative over here. Right? I'm allowed, cosine's allowed over here. So on a negative 1/2. And yes, there it is. And there's my radian. Excellent. 2 pi over 3. Make sense? Okay, let's try another one. Number 6. You're going to have the secant of the inverse sine of root 3 over 2. I think you can see it better down there. Guys, if you're watching online, my screen doesn't work, so that's why I made it clear. Okay, don't worry about the secant yet. We'll get there. Find the middle part right now. Find me the inverse sine of root 3 over 2. Find that for me. Remember where you're allowed. When is sine positive? Y is positive up here. So these are my options, and there it is. So I have a pi over 3. Did everybody agree with me that this is pi over 3?
Yes.
All right, so you're there. You're getting closer to the answer. Here's the problem. Where do we find secant? We can't. But what do we know? What is the reciprocal of secant? Starts with an S, so reciprocal starts with a C, right? Its reciprocal is cosine. So in your head, on this part, okay, you're going to say to yourself, all right, I'm going to think, good notes on this part, guys. You're going to think, what's the cosine of pi over 3? That's what you're going to think. So at this point, you're going to say to yourself, you need good notes on this part. Think, cosine of pi over 3. So I'm going to erase what I have and start all over. All right, I'm giving you a radian value. Find pi over 3. Where am I? Where I start? Pi over 3. What's cosine? Where is it? Cosine is 1/2. Agree? Okay, so this answer is 1/2. What do you think I'm going to do with that 1/2? Flip it. So instead of 1 over 2, I'm going to have 2 over 1, which is 2. So the answer is 2. Good. Right. We won't be able to use a circle. You have to flip it. That one's hard. Just try another one like that. Number 7. Cosecant of the inverse cosine of 1/2. Cosecant of the inverse cosine of 1/2. It looks like a negative 1/2. It's not. I want the cosecant of the inverse cosine of 1/2. Just the way the paper sits. Give it a shot. You can't get good at this if you don't do it. If I keep feeding you the answer, it won't help us out anymore. You start in the middle. Find me the inverse cosine of 1/2. You're finding cosine. You're looking for when x is positive. Go to the x-axis. X-axis, positive cosine, right there. Agree? Okay. So its value is pi over 3. So now I'm looking for the cosecant of pi over 3. We can't find cosecant, so we have to find its reciprocal. What's the reciprocal of cosecant? Sine. So over here, we're going to think. You're going to think for a second. So I'm going to look for sine of pi over 3. And when I get my answer, kids just try to flip pi over 3. No, you don't flip pi over 3. Get sine of pi over 3. What is sine of pi over 3? Here's pi over 3. Here's the sine value. So it's root 3 over 2. But root 3 over 2 is not your answer. What are you going to do to root 3 over 2? Yeah. Now you flip it. Wait a second. When I flip it, I get 2 over root 3. Right, so it's 2 root 3 over 3. Root 3 over 3. Okay, last one. And then you're going to try them on your own. Number 8. Cotangent of the inverse cosine of negative 1/2. Cotangent of the inverse cosine of negative 1/2. cosine to be negative. You want the x-axis to be negative, which is over here. You're not allowed down here, so it's here. I want negative 1/2, so here's my cosine values. Cosine of negative 1/2 is here, which gives me 2 pi over 3. So now I want the cotangent of 2 pi over 3. You can't find cotangent. So you find tangent and do what to it? Right. So you think, okay, tangent is, there's 2 pi over 3, tangent is negative root 3. And then you're going to flip it, which gives you negative 1 over root 3, which is root 3 over 3, and it's negative. Because remember, if cotangent is negative, tangent is negative. Does that make sense? Okay. All right, so that's it. I'm going to give you some to try on your own.